So this is about Amazon forecast. It was announced yesterday by Andy Jassy. And I'm here to give you a little bit more kind of color around the product and what the service does, what it's capable of, and so on. My name is Bindu Reddy, and I'm a general manager at AWS AI. We're going to start with the overview of the service. It's going to get slightly technical, much. But then after that, we're going to have like a science presentation by our senior machine learning scientist, Jan. And then finally, we're going to end with a customer presentation, 21st Century Fox, who's been trying out our beta service. Who knows what time series forecasting is? Quite a few people. OK, so for the people who haven't heard of this or are like intrigued by the whole thing, it's basically the science of predicting future points given historical data. Think of it this way. You have a curve, and then you want to predict what the curve will look like in the future. And in some ways, this is completely interesting and fascinating, because what we're really talking about here is predicting the future, right? If you think about time series forecasting, it applies to pretty much anything. Weather forecasting, stock forecasting, all kinds of forecasting. And if we could actually forecast with artificial intelligence accurately all the time, we would pretty much know what the future looks like. So we have to think about time series forecasting with the idea that forecasting is a very inaccurate science, in the sense that you can't actually be completely accurate, but you can strive for accuracy. And given that starting point, let's think about all the various different places where forecasting can be used. And it's surprisingly useful across many different business domains. This is one of our favorites, for obvious reasons. So at Amazon, we started with selling books, right? And we were selling a few 100,000 books. And if you know the origin story for Amazon, Jeff Bezos and his crew were literally packing up these books and actually selling them. Now we sell millions and millions of items to multiple different countries. And the only reason we can do this, and do this in a way where you can get your book or get your electronic item or whatever delivered on time, is because we know how to estimate demand. Meaning, we know how to tell how many items of a particular product we're going to sell on a particular day. As an example, if you've ever bought something on Prime Day, you'll know that our traffic as well as our demand that those days goes sky high, right? So we need to know exactly how many Harry Potter books to stock, or we need to know how many latest speaker, which is sold by Sony or something, to stock as well. So product demand is a really big use case for forecasting. So if you can forecast the demand of a product, you basically know exactly how much you will sell so that you don't actually ever go under stock. So because if in the end of the day, if you end up getting 10,000 orders for a Harry Potter item, and you have only 3,000 to sell, you've lost 7,000, correct? Similarly, if you went and stocked 100,000 items of the Harry Potter book, and only sold 10,000, you're overstocked, and you're using fulfillment center space, you're using store space. Of course, this applies not just to Amazon, it applies to every single retail store in the world. If you go into Whole Foods and they overstocked with lettuce, and you actually wanted chicken, we're in trouble. So being able to forecast product demand right is extremely, extremely important. The second thing is workforce demand, right? This is also something which is really applicable to businesses where you have a lot of temporary workforce, and there is seasonality in that workforce. Again, Amazon. For Prime Day, we have to get a lot more people working at our fulfillment centers. We need to know exactly how many people will work at which particular location, and we need to actually know that 3 to 6 months beforehand, because we're going to have to hire these people. Take reInvent. If you don't know how to forecast how many people are going to come to reInvent, how many casinos you're going to know, how many casinos you're going to use, and how many people we're going to hire, we're not going to be able to run this conference as smoothly as we do. So forecasting workforce demand is another big use case. I'm actually not exaggerating here when I say the essential science that Amazon has developed over the last few years has been forecasting, because that's what we needed to excel at to actually become who we are today. The third example, of course, applies to every single organization, right? Who doesn't want to forecast their finances? From personal finances to organizational finances, everybody wants to know what cash flow, revenue, sales is going to be in the future. So if you could actually tell that, you would know which companies would do really well and which companies will do badly, and you could buy the stock of the companies which do well. Third one, the last one here, very related to the first one, is inventory planning. Now, every manufacturer in the world has to be able to forecast how much demand that they have for their products. Let's suppose you're a big conglomerate, right? And you're a big manufacturing conglomerate, and you're producing, like, say, 10,000 TVs or 10,000 brands of TVs. You better know how much to, like, produce of each particular brand. You know, if you're, say, for example, if you're a company like Apple, they'd have to know how many, like, iPods they're going to sell. Or a company like, you know, any other company which is a manufacturing company needs to know how much to make, how much they'll sell, and how much fulfillment center / any kind of warehouse space they need. So the point I'm trying to make here is forecasting is really, really important. Now, considering forecasting is really important, the most important thing about forecasting is accuracy, of course. Because a bad forecast is not a forecast. It pretty much is useless. And there are two issues, right? You have to get it just right. If you actually over-forecast, you end up, like I said, with wasted resources. Under-forecasting basically means lost opportunity. So a recent study, which was conducted, basically proved that a 15%, just 15%, a 15% improvement in accuracy leads to 3% improvement in pre-tax profit. So this goes directly to the bottom line, because you're really optimizing your resources. So because forecasting has been so important, it's also pretty clear that over the last few decades, there has been a lot of ways in which you can forecast time series. In fact, if you open up Microsoft Excel, I'm pretty sure you can say forecast, and there'll be a trend line which is drawn, right? So there's been a lot of methods around there which will actually do forecasting for you. But there are many issues with these methods, especially if you want to consider the business critical use cases that I just defined. The biggest one is they can't really handle seasonality. Like if you draw a trend line, the trend line might not know that in December you're going to have higher sales, right? So it has to be able to handle the spikes and the seasonal spikes that you see throughout the year. The other thing is trend lines don't consider metadata. So what do we mean by that? So let's just take the example of selling a bunch of Beanie Babies, right? And let's say we had 5 different types of Beanie Babies to sell. And if you use some traditional method, all you're going to do is look at the history of how many Beanie Babies you sold in the past, and then try to predict the future. But if you knew a thing or two about the Beanie Babies, so for example, if you knew that some Beanie Babies were pink, and the pink ones sold much better than the blue ones, or if you knew that if they were more fluffier or what have you, they'll sell more, you have metadata about that particular type of item. And if you could give the algorithm this kind of information, and if that algorithm could make use of that information, it would obviously be extremely useful when predicting future time points in a time series, right? So including metadata is essential, but most methods don't consider it. The other thing, and this is the hardest one, right? The reason why we can't predict things accurately is because there are so many factors which go into that particular event happening in the future. So if there's a holiday, you're going to sell more. If it's if it's a busy working day and people don't have time to spend on Amazon or what have you, you're going to sell less. If you're going to have a promotion, say, on Facebook or Google or wherever, you're going to sell a lot more, again. And considering that in the algorithm is really, and the model is really important. If you don't consider it, and again, if you just look at the past, and let's say you had like a big promotional spike. Maybe you had a big promotional event, you sold 10,000 more products, or you had a big spike in demand in some ways, and you just looked at historical data. Again, the model you create will be wrong, because it did not know that there was a promotion at that particular point in time. In the end of the day, machine learning models are pretty much like humans, right? The more information you can give the machine learning algorithm or the model, the more information, the more it will make use of that information, and the more accurate it gets. Finally, almost none of the traditional methods can handle time series with no history. By definition, if you're going to take history as your input, if you don't have input, you're not going to be able to come up with any output. So what we've discovered over the last 20 years of working in this field, and probably hiring, I would say, 200 to 300 plus machine learning scientists, is that deep learning and using deep learning methods increases forecast accuracy, especially when you're dealing with multiple related items, right? Deep learning won't help you if you have just like one time series, right? If you have like 1,000 time series which are related to each other, which basically implies that you have 1,000 time series, for example, of all the products you're selling on a website. Or you have 1,000 time series of all the metrics that you want, because your product suite, for example, AWS, has about 150 services or so. So if we had all the revenue of all these products, and if we could actually feed that in to create a deep learning model, it's very likely that the prediction, the revenue prediction in the future, is more likely to be more accurate than just feeding one time series. So what we've discovered by doing multiple experiments over the last few years is not only does deep learning improve forecast accuracy, we can also tweak some of these deep learning neural nets and actually make algorithms which are invented by Amazon. And these algorithms, such as MQRNN, which we talk about here, and which is a paper which we published a couple of years ago, actually improves accuracy pretty well compared to other methods, especially on retail demand data. So in this case, the paper talks about us running this algorithm for 60,000 or so products. And you can see that it actually does a pretty decent job of actually capturing demand for a time series which had no past data, right? Figure graph 3 had no history. It was a brand new book or a brand new skirt or what have you, and it started getting demand, and we started forecasting it. Similarly, the last one is about promotions. There was a spike because of some promotion we did, and then the forecast algorithm caught it and also predicted that spike right there. So what did we do? So after learning a lot about forecasting and after learning about some of the methods over the last few years, which makes forecasting more accurate, we realized that being part of AWS, we like to bring the technology that we've developed internally to all of you guys. So we're very, very proud and happy to announce Amazon Forecast, which is an automated forecasting platform. Amazon Forecast draws from 20 years of our experience so far. And throughout our tests during private beta, as well as through tests which have happened inside of Amazon, we've seen that it actually improves accuracy by up to 50% over traditional methods. Now, to make things a bit more interesting, we've actually packaged, along with the deep learning methods that we've come up with, some of the traditional methods used today for forecasting. And why did we do that? We basically wanted to make sure that you can benchmark. You can say, hey, if I use something which is more traditional, like ARIMA or exponential smoothing, or Profit, which is a Facebook library, what does my forecast look like? So let's use the traditional methods and generate forecasts, and then let's compare it to the Amazon deep learning ones. And ideally, the situation should be that the deep learning ones do better. And so far in our experiments, we have actually proven that, as I said before, that deep learning will work well, but we want you guys to actually experiment and benchmark and basically use all the tools that we have in our toolbox. So with Amazon Forecast, we solved some really hard problems with forecasting. Probably the most important thing that it does is it learns relationships between multiple related time series. Now, this is the example I just gave you before. Let's say you had like 50 different time series of all the revenue trends of the 50 different products you sold. What Amazon Forecast will do if you create a model using Amazon Forecast is it actually starts learning that database products probably behave similar to each other. Or infrastructure products or compute products will behave similar to each other. So it starts learning patterns in these time series. It starts figuring out these groups and starts saying, oh, OK, wait. Amazon Forecast is a machine learning product, so its revenue probably will look like other machine learning products. So that it can automatically pick up on, which is really cool. It can incorporate external data. With one flag in the API, you can say, hey, include holidays, because holidays matter to me. Include the fact that this day is a holiday, and therefore I'm going to have some kind of change in my forecast. It can generate forecasts for new items. We showed you an example with MQRNN already, which which actually handled new items which didn't have history. So Amazon Forecast comes with these algorithms. In fact, Jan will tell you about all the fancy stuff which comes with Amazon Forecast. It's pre-built with 8 algorithms which are packaged as recipes. 3 of them are traditional, ARIMA, ETS, and Profit, and 5 of them have been developed by Amazon. Finally, it can predict spikes accurately. You can, again, in our forecast API, you can pretty much, when you're giving us your data set or when you're giving us your data, you can tell us when you are running a promotion. All you have to do is to say promotion yes, no, and then it can start figuring out when there is going to be a potential promotion in the future and whether there is going to be a spike. So as part of the automated time series forecasting platform, the key features we offer are it can forecast any time series. A lot of the examples I gave you were around product demand, but this also works for metrics. It works for cash flow. It works for workforce demand, and so on. So it's a generalized forecasting service. This is the cool part, because what it really does is it actually creates a custom deep learning model based on your data on the fly and generates forecasts from that model. The reason why this is interesting is that if you look at your standard machine learning products and services which are available today in the market, most of them come with pre-trained models. So take vision, for example, computer vision. You're going to send, typically it's an API. You send the API an image. It'll detect objects in the image, and it'll return back with, OK, there's a hot dog in this image or a cat in this image. And the way that works is there is some pre-trained model sitting in the back end, and it gives you results based on what that model comes up with when you run an inference call on it. What Amazon Forecast is doing is it's actually creating that model for you based on your own data. So it's a custom deep learning model which has been trained. Your data is not shared with anyone else, and that model actually applies to your data, and therefore it can do a better job of forecasting your data than anyone else can do. And this is one of the first machine learning services of its kind. And Amazon's very proud to have been the first company to do this. You can visualize and override forecasts. Now, typically, all AWS services come with a console, right? But the console usually allows you to do a few things, and you have to go off and do your API. It isn't really much of a consumer console. You actually can't see the results directly. With Amazon Forecast, we've actually made some improvements across some of our new services now, where we're able to actually give you the ability to visualize a particular forecast. So once you've decided that you're going to train a particular model, and then after you've trained your model, you're going to go generate forecasts with a single API call, then you want to go see the forecast. You want to see what the visualization looks like, and Amazon Forecast has a section in the console which will do that for you. Now, typically, what we've heard from our customers is, OK, we like your forecast, now what? You've generated a bunch of forecasts. What are we going to do with this? And their answer really is, you want to take those forecasts and feed it into your downstream ordering system, right? You want to feed it into whatever it is that is going to make a decision in terms of what you're going to buy, what you're going to sell, and what have you. And with Amazon, that's what we do. The reason why we're calling it an automated time series forecasting platform is we use forecasting models today to forecast product demand, fulfillment center space, workforce demand, all automatically. Very little, if any, manual intervention involved, because manual intervention would be impossible with hundreds of millions of products. By definition, we would need something which is pretty technical and which is pretty accurate. So given that, we take that data and we feed it back into our ordering systems. But most of the organizations and AWS customers today have ordering systems which are usually based or are sold by Oracle or SAP. So with Amazon Forecast, you can actually take that forecast and bring it back into Oracle or SAP, where you can then do ordering based on it. So as I said, Amazon Forecast is applicable across multiple different domains. Out of the box, it comes with what we call schemas and domains. And the domains that come out of the box are retail, inventory planning, EC2 capacity, workforce, web traffic, and metrics. So if you wanted to forecast any of these things, you would choose one of these domains. But if you had something completely different, you were like, hey, my time series forecast is about some completely different thing. We're going to be predicting, say, IoT sensor usage or something. Great. You can create a custom domain. You can set up the schema on that custom domain. And you can then upload data sets with those schemas onto the domain, right? So think of it in a, I'll give you a very simple example. Let's take retail, right? The first domain that we have. What we basically prescribe is a schema which says, timestamp, tell us when something happened, how many units did you sell, demand, and what is the product. It's called item, so item ID. That's it. That's your schema. You have to create a data set based on that schema, and then you have to provide that to Amazon Forecast for it to create a deep learning model, which you can do with 5 clicks on the console. You can also use 5 API calls if you don't like consoles. So the first call is to set up your data pipelines. So I just talked to you about the schemas and the data sets. In that data set, you can also say, hey, pick up my data from S3 on a regular basis. So you can set up whatever cron you want. You can pick up the data every hour, every day, or every week. And you will be dumping your data on that regular schedule onto an S3 bucket. And we will pick it up automatically. And then we will use that data to generate the deep learning model. The second step is for you to decide whether you want to use one of our pre-built algorithms or just basically call Amazon Forecast with the AutoML option. So that's really simple. It's an API call where you're creating a model based on your data. So the API call is called create predictor. And in that call, all you do is say AutoML enabled. That's pretty much it. When you switch that flag on, what it does is it goes through all the algorithms we have, and it tunes all these algorithms for your data set and picks the right algorithm based on your data set. So it's literally as if it took care of all the tweaking and the tuning and the experimentation and all of that stuff that you have to do as a data scientist or an ML scientist, and abstracted that away into one API call. Now, if you don't want to deal with machine learning and don't want to know any of this, that's fine too. All you have to do is to make this API call, and Amazon Forecast will do the rest. Once you have that predictor created, which is in many ways analogous to creating a forecasting model, you really care about how well this model does, and you really care about accuracy metrics. Because initially, I said, look, forecasting doesn't make any sense until you're accurate. So now you're going to have to figure out what metrics make sense for you, and whether those metrics are good, whether those metrics that are output by that model are good enough for you to go off and deploy that model. So let's say you experimented with 100 different models using Amazon Forecast, right? Then you got a bunch of different accuracy metrics, and you were like, this is the best accuracy metric, I like it. This particular deep learning algorithm from Amazon DeepAR is actually outperforming everything else. Let's pick the DeepAR recipe. Let's generate those metrics, and then go off and deploy the model. Deploying the model is, again, one API or one click. When you deploy the model, what it actually does is it runs inference. It takes all of the time series you gave us in a data set and basically predicts future points in those time series. And then finally, you can generate forecasts. And the generation of the forecast will help you either actually generate the forecast data and export it in a CSV format on a regular basis, or you can actually use an API and make single API calls to get forecast information. Diving a little deeper, and I'll go through this really quickly because we kind of went through the last couple, the process in a pretty detailed manner already. We take historical data, and then we take the related data. Historical data is the historical time series data. Related data is things like holidays and product descriptions and promotions. We upload that data into Amazon Forecast. Amazon Forecast in that orange box does all of that stuff. It creates a optimized model. You can then export these forecasts either in CSV format, or you can export it using an API, and of course, you can visualize it. So when it comes to data ingestions, we talked a little about the data sets that you needed to create. There are 3 different types of data sets in Amazon Forecast. The first one is really simple and the only one which is required. So if you're one of those people like me who doesn't really like handling too much data, you could just be like, OK, I'm just going to do the target time series data. We'll start from there. We'll see what kinds of models the service can produce. So historical time series data is the primary one, which is just basically historical data. The is the secondary one, and this actually matters a lot when you think about like retail. The reason why this matters so much is clearly the price of the product has a direct impact on the sales of the product, right? If you overprice the product, or if you just decided, hey, I'm going to just increase the price of this by 100%, what will happen? Demand will go down. And how does the algorithm know that if you don't give it price? So by giving it price, it actually can tell, like, wait a second. If your price is going to go up by 100% tomorrow, you're not going to be selling the 10 items you were selling today. You're going to be selling 3, because a lot of people are going to walk away. Sorry. The last part of that was the item metadata, which is stuff like genre, brand, color, which is associated with each of these time series. So it takes all of these 3 different types of data, and then that's when it uses this data sets to create this pre-configured algorithm. Once the algorithm gets created, you can start comparing the accuracy metrics. And this is something which I wanted to spend a little bit more time on, because the way we think about accuracy is a little different from traditional methods. If you think about a traditional method and you say, hey, what is the prediction? The traditional method will basically say, like, take the Excel example I gave you. If in the future, this particular time series, this particular value will be 20, right? It just gives you one particular prediction. We think about this as probabilistic forecasts. Jan is going to explain a lot more about what this is and how we think about this. But really think of it this way. It's the probability. We basically compute a histogram of all the various different demands that we predict with a particular probability. Meaning, what is the demand, or what is the forecast going to look like? And what is the probability of that value being the actual value? Say there's a 10% chance of the actual value of the forecast value being 10. If the forecast was 10 and there's a 10% chance of it actually becoming 10, then that is the probability by which we decide, hey, this is how probable this particular event is going to be in the future. So we use these prediction intervals, and we give you the error, which is MAPE, based on these different prediction intervals. The one interval I wanted to focus a little bit on, and Jan is going to go a lot more into detail about this, and the one which Amazon uses the most, is this thing called the P90 MAPE. Now, what the P90 MAPE is it is our forecast prediction where there is a 90% chance that the observed value will be less than the forecast value. Okay? So what I'm saying is the observed value, which is the actual demand, will be less than the forecast value, and there's a 90% chance of that. That is the P90 value. And that's the P90 forecast. Why is that important? Because we want to make sure that we're overstocked, and we're able to actually deliver the demand we get, slightly overstocked. Right? If you go way overstocked, you're going to be spending a lot of money, but you want to, at any point, be able to satisfy your demand. So if tomorrow, we have a bunch of customers who come in, and they want the Harry Potter book, we want to be able to sell it to them. So the way we do that is we want to make sure that the real value, that the real demand, there's a 90% chance that the real demand is always below this P90 number. And this is what we recommend to all our AWS customers. If you're going to use any kind of forecasting with respect to forecasting demand and using that for business critical decisions, P90 is a good number to look at. There are other confidence intervals you can get forecasts on too. We can talk to you a little bit more about those use cases as well in Jan's section. So once you deploy this predictor, which is the model, and generate these forecasts, because now you like your accuracy, you can use an API to schedule forecasts to be generated on a regular basis. So this is kind of cool too. You don't have to generate the forecast once, and then you don't have to manually go off and generate every day. You just set up a schedule, and it generates the forecast every hour, or every day, or every week. Just like how we pick up the data on a regular basis, we also forecast on a regular basis. And finally, this is our Amazon Forecast Console. It's pretty easy to use, pretty much like most of our other AWS consoles. The 3 important pieces are importing your data that I talked about, training a predictor, using one of those recipes, or doing AutoML, and generating forecasts. And you can do a lot of these steps right from the console. And this is a screenshot of how the visualization looks like, right? Once you've actually generated these forecasts, you can put in an item. You see that item ID there? Think of it as a particular type of Beanie Baby or what have you, right? You put in that item ID, and you can actually get forecasts and visualize them. Finally, before giving the stage to Jan, I wanted to talk to you a little bit about some of our beta customers who have been using Amazon Forecast. Some of them actually have been trying it out for the last, I would say, 8 to 10 weeks. Mercado Libre has been one of them. And they are using it to predict demand for over 50,000 products. I would say that they've actually tried out a whole bunch of different models. And the ease of creating these models, trying it out, experimenting with them, has been really good for them because they can easily now compare these models against some of their benchmarks and see how to get the best forecast. Another company which has been using Amazon Forecast is CJ Logistics. In this case, they're optimizing the amount of human resources, transportation, and work and warehouse space. So slightly different use case from Mercado. And in their case, actually, they could actually get accurate forecasts pretty quickly. They didn't take that much experimentation, and they have a clear vision on how to use the Amazon Forecast in their day-to-day operations. I'd like to now invite Jan, who's going to talk to you a little bit more about the science behind forecasting.
All right, thanks, Bindu. So I have about 7 minutes, so I'm not going to go into that much detail, and I even resisted the urge to put equations on the slides. But I'm going to tell you a little bit about, I think 3 aspects that make the algorithms that we have in Amazon Forecast stand out from what some of the competition has. But first, I'm going to start with a quote. So I think we already hinted at this. Of course, we want to give you, the right forecast. This always gets the prediction perfectly right. But of course, we have to acknowledge that, forecasting is actually a hard problem. So we have to embrace the fact that, in any real situation that we're going to make a forecast, we're probably not going to be right 100% of the time. Let me step back a bit, and this is probably what most people think of when they hear forecasting, right? You have some time series, which is sort of values indexed by time, that looks nice and regular like this, and you want to make a prediction about how this time series is going to continue in the future, right? And if I asked any one of you to sort of draw how this will look like in the future, you'd probably come up with a pretty good answer, right? In this case, it's pretty easy to see where it's going, and you might come up with something like this, right? Now, in practice, this is basically never how it pans out. This is not the situation that you're actually dealing with. In practice, you have something that's much more like this, right? You don't have just one time series that's super nice and regular. You have maybe 100 or 1,000 or even 10 million time series, and they're messy, right? They're not just a nice, a trend plus some seasonality. They're, super noisy. They have, maybe missing values. They have all sorts of effects going on, some of which Bindu already mentioned, that are actually very hard to deal with, especially if you're using some of the classical methods. Now, 3 of the features that we have in Amazon Forecast that make it a bit easier of dealing with this sort of more complicated problems is that, first of all, we fully embrace the fact that sometimes we're going to get the forecast wrong, and if we do, we want to know how certain are we that this forecast is actually correct. So we're actually making probabilistic forecasts instead of giving you just one best value. We learn across time series, which makes it possible to deal with noisy data that has all sorts of crazy effects. It's not just a trend and some seasonality. And we allow you to learn with covariates. So what Bindu mentioned are, for example, like price and promotions and metadata about the product, like the description or maybe even the picture, right? This is all information that allows you to tell how products are related to each other, which products are similar, and we can exploit that information to make better forecasts. Now, to the first point, let's embrace the fact that the forecasts are most of the time in any real situation going to be wrong, right? But we can actually, we don't have to give up at that point. We can take a wrong forecast and still get some use out of it, right? And the way we do that is instead of saying, this is my one best value forecast, and maybe this is the truth, right? And I'm getting it wrong. Instead of doing that, we actually give you a full probability distribution of the values that you can expect in the future. Right? And what this allows you to do is that, so the way to interpret this is basically that the top part of this yellow band that I'm showing here is, in this case, what we call the 90th percentile, which means that we, if the forecast that we're making, the probabilistic forecast, is accurate, then 90% of the values that we observe in reality should be below this top line of the yellow band, right? And similarly, the bottom line here is what we call the 10th percentile. So, 90% of the cases, your actual values should lie above this particular band, right? So with that information, this is much richer than just giving you the best forecast, because you can actually now know, how certain am I? And in some cases, the algorithm can say, this data is, I just really don't know what to do with it, and it's going to give you a wide uncertainty band, right? And it's not going to tell you, okay, I'm very certain that this particular event will happen, and then you take the wrong action based on that. Like imagine now we make a forecast that you're going to be selling 10,000 products of this particular kind tomorrow, and then you actually only sell 10, right? That's really bad. But if we tell you, the band is between 10 products and 20,000, then you're probably not going to go and buy 10,000, right? You're going to maybe be a bit more pessimistic, right? Another thing that allows you to do is to basically to meet sort of the service level that you want to be offering to your customers, right? If you're a retailer, you don't want to be out of stock 50% of the time, right? You probably want to have this number to be much higher. And one of the things that Bindu mentioned was this P90, which is basically basically saying that if you would order such that you had this number of items in stock, right, then you would be basically able to satisfy your demand 90% of the time if your probabilistic forecasts were correct. So in summary, this probabilistic forecasts allow you to quantify your uncertainty. They support sort of optimal decision making, even when you know that your forecast is going to be wrong, right? And all of the algorithms that we have in Amazon Forecast support this, giving you these probabilistic outputs. Right. Now, the second thing I wanted to talk about is to contrast a little bit the classical time series models that people are mostly using today with sort of the deep learning models that we have in Amazon Forecast. Now, the classical models basically make assumptions about the patterns that you can expect in your time series. So, for example, in this time series, you see there is some sort of trend that's going up, right? So the classical model would assume, okay, there is a trend. In this case, let's assume it's a linear trend, right? And it will try to fit the best line to your data, right? And it will do that basically with all the sort of effects that you tell the models you think are in the data beforehand, right? So you have to tell it, okay, I think there is a trend. And maybe you also tell it, I think there is a seasonality, right? And then based on that, the model will find the best fit to your data based on these assumptions, right? So you're assuming that there is a certain pattern, and then you're finding the model. Now, there are some good aspects about these traditional forecasting models. They definitely have their place in making forecasts for certain situations. So the basically most important sort of good aspect about these models is that they have extremely high data efficiency, right? Because I'm making these fairly strong assumptions about what the data looks like, I can fit these models with very few data points. But of course, the flip side of that is that they can only fit the patterns that I told the models would be there, right? So if my data now has other patterns, so for example, I have some changes in there which are due to price changes or due to promotions, then these models will be sort of misspecified, and the forecasts that you get in return are going to be wrong. But for the cases where these models actually do work well, we have 4 of these types of models in Amazon Forecast, and some of them are good for some. They all have their sort of slightly different use cases, and you can experiment with which ones actually work best for your particular data set that you're looking at. And we have sort of 2 extremely well-known ones, which is the ETS exponential smoothing models and the REMA models. And both of these actually come from the R statistical computing language. So these are sort of the de facto benchmark implementations of these methods. Right, so the downside, of course, of these models is that they cannot identify patterns across time series, because all they do is look at a single time series at a time and match it to the assumptions that you have made. Right? And if your data doesn't match these assumptions, well, then the forecast is going to be off. Now, to contrast this with the deep learning models, where we have this situation again, where you have lots of time series, we have lots of data, so we can get away with making fewer assumptions, right? Because we can learn some of these patterns actually from the data without having to tell the model beforehand that these patterns are going to be there. Now, in Amazon Forecast, we have 4 of these models, and they're they're basically all developed by us in-house over the last 5 years or so. Some of these we have published papers about, some of these we are going to publish more papers about, and you can read all about the details in how these models actually work in these papers. But sort of the key highlights of these models is that they basically, we call them global models, right? They learn from all time series instead of looking at just one time series at a time. And that allows you to learn, group-dependent behavior. So for example, if you're a retailer again, right, and you're selling shoes and hats or whatever, right, then these things have different seasonality patterns, for example. And these models can learn these based on the data that you have. Right? If you feed in the information that this belongs to the particular group, or even just by giving it sort of maybe the product description, right, we can figure out that these are similar items and then learn seasonal patterns that are similar between them. The models make weak structural assumptions, so you don't have to tell it beforehand which particular features you expect to be there, which allows you to incorporate rich metadata. It allows you to make forecasts for cold start situations where you don't actually have a historical time series, and that can be significantly more accurate if you have enough data. Right. Actually, in the interest of time, I'm going to skip this part, and I'm going to hand it over to Louis, who is the Vice President of Data Science for 21st Century Fox, and he's going to tell us a little bit about how they're doing forecasting using Amazon Forecast.
All right. Hello. All right. Thank you so much, Jan. So before we talk a little bit about how we use time series forecasting, I want to mention a little bit about what our team is and what we do. So I lead the data science practice inside a team called Fox Data Analytics. And what we do is we find opportunities for AI and machine learning to be applied across the entire 21st Century Fox organization. And we mainly focus on 3 different areas. The first one is commercial opportunities. So how can we build models that help us optimize the current revenue streams that we have, and how can we build also models that can help us identify what additional revenue streams we could get out of the data assets that we have. We are also very focused on consumer analytics and try to identify consumer patterns that can help us build personalized experience for our users across all of our digital properties. And then we're also really focused on content metadata extraction because that helps our editors team by using computer vision and natural language processing that helps them tag those contents in a much more smarter way that can help them visualize them as soon as possible. So we are a global company, so we have more than 1 billion subscribers in 170 plus countries with more than 500 different channels across traditional TV and digital channels. So as you can imagine, we have a lot of work in our hands. My team is really, really busy. So we jump on any opportunity that we can find to make our work a lot more streamlined and a lot quicker. So when we first heard about Amazon Forecast, we were really excited about it. And when people think about time series forecasting, they usually think about, as Bindu and Jan were mentioning, retail use cases where you have multiple products that you want to be able to forecast demand for, or people think about predicting the stock price for financial companies, and we're neither of those. We're a content publishing company. So the use case that we were focused on is forecasting audience. And we have a lot of different audiences that we need to forecast. As I mentioned, we have TV broadcast channels, we have cable channels, we have digital channels and video on demand channels. So this is potentially like hundreds of different time series audience forecasting problems that we need to solve. And why is that important for us? So as a publisher, a lot of our revenue comes from advertisement. And the amount of money that is paid for a specific ad depends directly on how much audience is watching that ad. So for us, being able to accurately, or as accurately as possible, predict the amount of audience that are going to be watching our channels, and therefore our ads, helps us make better financial planning. It helps us plan our campaigns, the campaigns that we deliver for our advertisers, a lot better. It helps us reduce liability because we're actually not overcommitting the amount of people that are going to be seeing your ad or undercommitting. And it also helps us do an optimal scheduling of our TV grid because we can actually predict how well a specific show is going to do at different points in time. So why is this problem complex? So the two main reasons that make these problems complex is that if we use, for example, traditional time series models, some of those only take into account, as Jan was mentioning, that time series trend. They look for trends, they look for seasonalities, and they all basically only take into account the time. But if you think about this problem, we actually, I mean, the amount of audience that you're going to get on a TV show versus an NFL game or a baseball game is going to be very different. So the actual category of the content is important. It's also going to be different if the show that you're broadcasting is a season premiere versus a repeat of an old show. Like all this metadata is really, really important for us to be able to improve the accuracy. So we need to make sure that whatever model we use is able to capture all this metadata. On top of that, we also have a lot of related time series because we have a lot of channels that are broadcasting content at the same time. We also have a lot of competitors. So the content that our competitors are displaying also can affect the amount of audience that we're going to get, right? Which we call audience cannibalization. If they are displaying a very popular show at the same time that us, so a lot of that audience is going to shift to that other channel, and that's going to affect our forecast. So before working with Amazon Forecast, we basically had three things that we were exploring. The first one was the traditional autoregression models that Jan was talking about, which take a look at those trends. And those, as he mentioned, we cannot include metadata about the content to be able to forecast, which is a really big con for us. And it also doesn't consider relationships in between time series forecasts, which we said it's important because we want to understand like, how more audience in one place is going to eat up audience in another place. We have other models like traditional regression machine learning models. One of the most popular ones is XGBoost that actually allow us to capture all the different metadata. But the problem with these models is that they do not consider the sequential nature of the data. They do not consider that all these different observations happen at points in time that happen one after another, right? So one of the best approaches is to actually use deep learning models. And some of the models that were mentioned before are some of the state-of-the-art deep learning models that we have been trying. But the problem with this is that usually deep learning models are really difficult to implement. And they also are really difficult to fine-tune. You need to figure out how many layers, what activation functions are you going to get. So it's really, really time-consuming to implement and fine-tune. So this is what we are seeing that Amazon Forecast is helping us streamline all this work. First of all, in terms of data preparation, so there's a lot of pre-processing of this data that needs to happen before we even fit it into the model, like making sure that all your parameters are normalized, you get rid of all the missing data and all that stuff. So fortunately, Amazon Forecast takes care of all of that for us. Also, in terms of model creation, it supports out of the box a lot of the most popular models and even goes farther, implementing some of the state-of-the-art deep learning models. So, and they do it in a way where they actually fine-tune all those hyperparameters for those models automatically. So we don't have to worry about having to run multiple iterations and multiple experiments to be able to figure out which parameters work the best. And finally, it helps us do model evaluation because we can just click the button, let it run, and it will give us the results for all those different models from traditional to more advanced, and then we can see which one is the best one that works for the specific use case that we're trying to handle. And yeah, that's pretty much it.
Thank you. Thank you so much, Louis. We were hoping to have a slide here, which basically, oh, it's there. Okay. So if any of you are interested in signing up and checking out the product, you can do so by signing up for the preview. We will be able to whitelist you most likely in a few days. probably next week. So all you have to do is to go to aws.amazon.com/forecast, fill out a simple form, and we'll have your application, and we'll send you the whitelist once it's confirmed. And finally, you can also provide feedback about this session in your mobile app. Thank you. And thanks for coming.